Hello, everyone. My name is Bruce Momjian. It's wonderful to be speaking to you today as part of DevOps Stage. Unfortunately, I'm having to speak to you remotely, but hopefully someday I will get a chance to speak to you in person and meet all of you. I am a employee of EDB. I have been for 15 years. I'm one of the Postgres core team members and have been involved with Postgres for 25 years. This talk, along with many others, are available on this website right here. So if you'd like to see these slides or others, feel free to go there. There are 54 presentations and I believe 92 videos of me giving presentations, mostly about Postgres. So if you're interested in that topic, feel free to take a look. The topic today will be database containers in the cloud. What I'd like to do is walk you through the journey of traditional IT, traditional deployment, then talk about containers and kind of where they evolved, and then finally explain how databases fit into the container world. It's not a perfect fit. There are some aspects that containers work very well with databases, and some of them are just not very useful. So I think this is a sort of a hybrid. We're going to talk about containers. We're also going to talk about databases and how you can use them to work efficiently, get more work done, and to make deployments easier. So what am I going to be talking about today? First, again, as I said, we'll talk about the traditional database data center, and then talk about containers, kind of where they came from, what infrastructure they're built upon, and sort of break down the various pieces. Then we'll talk about database containers and where that makes sense. And then finally talk about more specifics, how the cloud features work and how they benefit databases. And finally, databases in the cloud. Both, I'm going to talk about containers and the cloud kind of together. There's certain similar benefits to both of them. Not one is not necessarily better than the other, but again, depending on what your deployment requirements are, one would be preferable. So traditional data centers, and I'm going back way back to the 60s here, were basically physical media. This is punch cards, if you're not familiar with. That actually predates me even. I'm post punch card era, but in the punch card era, obviously, when you wanted to store information, you typically stored it on these punch cards, whether it's programs or data. And then later on, we had magnetic tape. If you've seen like the old movies that had reel-to-reel tapes on the wall, that was another way of storing traditional media back then. This is a picture, I believe, from the 70s, very famous IBM System 360. It might be late 60s, where you have a data center. In fact, we can see, I think, the reel-to-reel tape right here. Here's one, here's two reels here. Here's two reels over here. This is sort of the way things were set up. It would be on a raised floor in a locked room and so forth. We have two disk drives over here, and then the console here in the center, and you have sort of a bunch of people just kind of standing by to service that single system in one machine room. Typically, data came into this machine room mostly on punch cards, although tapes were also brought in to sort of get data in. You had teletypes, which you could use remotely to kind of enter data and run reports and plotting devices and so forth. But again, we're still a little more tied here to physical media, physical storage. This is more my area. This is the 1990s. I had a lot of customers who ran the HP 9000 series computers. This is obviously an all electronic server. There's not a whole lot of, there's no paper, there's no punch cards, there's no paper tape, there's no reel-to-reel magnetic tape. Most of it's disk drives. You have networking here. You have dumb terminals, if to some extent, at least for the console. This is a big step up, but again, we're still in a single data center. All of the information from the whole organization goes into this computer and comes out of this computer. This was a big workhorse for databases, this type of computer. We used to run Informix on this hardware. And we had backup tapes and different disk drives that went, SCSI disk drives that went in. And this was modern, I guess, in the 90s. Fast forward to today, there's obviously been a huge consolidation of data centers now. This is a Google data center, but again, Amazon would look the same. Azure would look very similar. Internal IT data centers, like for example, for Cisco, the data center may be used for Zoom, would look very similar to this kind of setup. You're now looking at 1U or 2U racks. Oops, sorry. This is a 1U or 2U rack right here. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 here. This looks about the same. So maybe there's 12 or 14, 16 maybe per rack, and then the racks are just kind of lined up. So, and then this cage up here at the top typically is used for running wire, right? Running networking wire. So you have a much greater consolidation of IT into centralized locations where you can have economies of scale. You can have a dedicated group of people, perhaps managing hundreds or thousands of servers, perhaps. And you're then, instead of having like one, like what we used to have one computer and everyone would just focus on that thing, now you've got a small team of people, managing many, many, many servers. A lot of automation, a lot of deployment automation, a lot of fault detection that gets automated. So you're kind of, moving, if you think of the automobile as being unreliable back when it was developed in the early 20th century, becoming more and more reliable, requiring less and less repair, and then getting more specialized. This is kind of that evolution of a more streamlined, a more efficient kind of way of deployment. And there's no question that containers and cloud and virtual machines kind of are in that era where you're moving away from bare metal into some more of a virtualized environment where things can be shifted around easier and moved around easier and managed more efficiently. So let's jump into containers. This is obviously a topic that there's been a huge amount of excitement in the past couple of years. Before that, it was virtual machines. So if you go back 5, 6, 7 years, virtual machines is what everyone was talking about, VMs, if you've heard that term. Now it's containers, and Kubernetes has been sort of, again, the one even after containers. So again, we've got a very quick cadence kind of where you've gone from VMs to containers to virtual machines. So let's dive into exactly what we're talking about here. So these are the three stacks I think of when we're talking about containers. Ultimately, containers are developed on top of something called Linux cgroups, which have been around for a long time. It's basically an abstraction layer that exists in the Linux kernel, which allows you to sort of segment off process ID management and permissions and file system management and networking kind of into its own bubble. And that kind of work on cgroups kind of was developed and just kind of sat there for a while. But then the Docker project came along and basically developed the containerized software on top of it. So you had the operating system support, but you didn't have sort of the deployment support or the containerization support on top of it. And that's what Docker brought to the process. And then after containers became popular, and Docker was traditionally run by a company called Docker, so it's open source, but it is sort of driven by at least historically a single company. And then Kubernetes, which is the deployment sort of infrastructure for Docker containers, came out of Microsoft. So you've got, I'm sorry, out of Google. So you've got sort of C groups coming out of there, Docker coming out of the Docker company, and then Kubernetes coming out of Google. And you sort of have this, as the needs got to be more abstract, and a new company kind of came in and sort of leveraged that and create a platform where everyone could be happy. The actual control of the software at this point is pretty open, but again, the original driving was behind those companies. So what is C groups? Let's talk about specifically what that is. It has to do with process isolation, resource control, CPU prioritization. So you can kind of see how this would start to sound like a VM a little bit, accounting, and then sort of freezing and restarting processes and groups effectively. Sort of the infrastructure behind containers needs that sort of C group operating system support. Then Docker comes along and builds sort of this containerized infrastructure. Where do you put the executables? You have the concept of a union file system where you can lay your libraries over top of the operating system you're running in. So you've got your container, and you may want to override some libraries and not others. So you have this union file system that sits on top and kind of blocks the lower level from being seen, and you only see the layer of the container. But other parts where you haven't blocked, you just use the operating system libraries. So that sort of library container, that library containerization and the ability to kind of filter which parts you want to override, pretty important. There's a specification file involved with Docker where you define the container. It uses C groups, as I said before, and there's namespace control, networking control, user isolation, again, built sort of on top of those C groups. And then finally, Kubernetes comes in, and Kubernetes is basically allowing you to automate the deployment of the containers. So we've talked about kind of the C groups, which is the operating system part, and then we talked about the need for the container. But how do you get that container started? How do you move it around? How do you scale it? How do you monitor it? How do you load balance it, right? All these things come from Kubernetes. So it's just kind of interesting that you've got like these different layers and they all came from different places. Docker has its own deployment language, but it's not that popular. Most everybody now is sort of using the Kubernetes for the deployments. And again, if you're just doing a couple containers, deployment may not be that complicated. But again, as your infrastructure gets bigger and bigger, automating this deployment becomes really important. And again, just as I talked about with the hardware, as you get bigger and bigger, you're going to need to automate more and more of what you're doing. And that's a fact. That's effectively what we're doing here. We're automating more and more of the deployment of these containers so that we can scale up much larger than if we had to manually control it. Finally, one of the interesting things coming from Kubernetes, and for those of you who are database folks have seen this coming, is the idea of a durable storage, or what Kubernetes calls a stateful set. Databases are, by definition, managing permanent state, and containers typically don't have permanent state. So you need some kind of permanent state for a database really to make sense in a container. Kubernetes provides that with the stateful set concept. And that kind of takes it, it bridges the gap between what containers need and what databases need. This is an example of basically Kubernetes running multiple containers on a single operating system. So you have a single Linux kernel at the bottom, you have 3 C groups in the middle, you have 3 containers on top of those, and then Kubernetes effectively manages the orchestration, creation, destruction, scaling, and so forth of these 3 containers. A more typical example of when Kubernetes would be used if you have multiple kernels. So here we have 2 kernels, 6 C groups, 6 containers, and then Kubernetes kind of sits on top of all those kernels, those 2 kernels, or might be many more, and then orchestrates where things go, what kernels or what machines each container runs on. And this is where you start to get some of the efficiencies, because you start to say, okay, this machine's very busy. Let me move a container off of there and put it on a machine that's less busy. That's fairly hard to do in sort of in a non-automated deployment. But with Kubernetes, you can kind of define how things move around. I'm not going to get into a lot of details here, but you can imagine that would be pretty important. Now, databases can't necessarily move around that easily because they're kind of stateful, and they've got they've got the stateful set, but still you technically can move them around, and there's a whole bunch of other parts you can move around if you want to. So this is where you start to get the efficiencies of being able to move your workload into different places. So we talked about hardware. We talked about where sort of hardware deployment's going. We talked about containers and container deployment, particularly Docker and Kubernetes. And now we're going to bring it kind of together with databases. And this slide, I think, really kind of encapsulates some of the I would say confusion or perplexed state that we had when these started to become popular. Because, as you may know, VMs, Docker, and Kubernetes have been popular for a number of years. And initially, the database community kind of looked at that and were like, well, yeah, I mean, the big value of these containers were rapid creation and destruction, right? So the example, if you have some kind of app that's doing something, maybe you want 10 of them, maybe you want 20 of them, and you just kind of fire them up and you route networking in there. And then as you get less busy, you kind of, you blow away a bunch of them and you only leave 3 of them. And you're kind of scaling this up and down, and then some other application comes busy and you create a whole bunch of those, and then you blow those away, and you do a whole bunch of testing. Databases don't really work that way. Yes, they can be used if you're doing testing. If you're doing load testing, maybe you want to be able to fire up a bunch of databases, run a bunch of tests, shut them down real easy instead of spending a whole bunch of deploying your own database. Yes, there is value to that. But in terms of production usage, you're not really going to be just creating and blowing away databases, partially because you got to load all the data in there every time you create it. And then every time you blow it away, unless you use stateful sets, the data's gone. So it's kind of not super useful. There are some sense that you could kind of maybe create the container only when you need the database, and when you don't need the database, you basically remove the container, but you leave the stateful set there. Yeah, there's some use for that, but again, that's not a typical database use. The second one, and this is more related to virtual machines, there's less overhead in a container than a virtual machine. Virtual machines, you're basically you're booting a brand new operating system on top of another operating system. And that overhead of having a VM and having to go through that VM for all the kernel calls and everything can be measurable overhead. But again, for database, it's doing some really heavy stuff. It's not that tied to kernel calls. Mostly it's tied to IO. So is there a whole lot of value to having less VM overhead for databases? Not really. It usually is a fairly minimal number that really doesn't move the needle. However, the last 3 actually are interesting. And the interesting thing is that most people looked at the first 2 and like, oh, that's why we have to use containers, right? And if you kind of talk to somebody, that would be the reason they would be excited. Oh, I can create stuff. I have less overhead, blah, blah, blah. And for a database person, you're like, yeah, okay, but that doesn't really apply to me. So I'm not sure really containers are great. However, there are 3 other values that containers have that you don't hear about a whole lot, at least outside the database world. And they're there, but they're not really the flagship reasons for containers. At the same time, they are useful. And particularly, I'll get into specifics later, but there are some pretty good uses for containers. The first one is scaling. And that is the ability to basically give additional CPU, additional memory, to fire up new servers, perhaps for read-only load balancing, for databases, and that's pretty useful. It's hard to do in a non-automated fashion. It's not something you probably want to do manually. I guess you could, but who's really going to be sitting around to say, "Oh, my database looks busy. Let me go fire up a new, server." It doesn't happen very often. But with Kubernetes and containers, you can kind of do that auto scaling in an automated fashion, and it's kind of nifty, right? It's kind of useful. The second one is migration. So you can basically migrate from one version of a database to another, kind of using containers. And that kind of isolates it, allows testing to be easier. And then finally, the last one, which I think is the unequivocal real value containers, is automated deployment. And I'm going to go into some details, but if you're just deploying one database or two databases with not a whole lot of tooling around it, maybe you don't need containers. But modern databases, you may be deploying hundreds of them, and each database may need its own tooling around it. And doing that in automated fashion becomes really difficult. So this deployment ease, which is sort of a footnote in terms of database value, container value, becomes this huge thing when you're talking about databases. So it took a while, I think, for the database community to kind of understand, okay, everyone's saying containers. The two things they keep talking about at most don't have a lot of value to databases, but these other three things, which they don't talk about as much, actually have much greater value. And there are absolutely needs to consider database containers for those three features. So I was talking about, if you're deploying 100 databases, not only are you deploying 100 databases, you're typically having to deploy 100 databases plus all their associated tooling. And getting that all right and consistent is difficult, particularly when you're talking about hundreds of servers. So the concept of automating deployment is that you can automate not only deployments of the database, the deployment of the backup software, the deployment of the monitoring, the deployment of the failover, the deployment of the connection pooling, and even scaling can now be automated. So you're not only deploying the database, you're deploying a pre-tested environment of tools around it that are all going to work because they're all the same. They're all deployed the same. You can update all the tools across the entire infrastructure with one operation in a unified fashion. Having that kind of consistency, because databases are very complicated piece of software, and you've got all this other tooling around it that's also very complicated. So the more you automate that, the more consistency you have, the more reliability you have, and the easier you have to understand how those things function. So again, great value, automating that tooling install, tremendously useful. So we talked about hardware, we talked about containers, we talked about containers in the cloud. Talk about containers for databases. Let's talk about cloud, okay? So we haven't really talked about cloud yet. We've kind of been just kind of fiddling with containers and Kubernetes on particular Linux kernels. Cloud features are obviously, all the buzz. Everyone is excited about it. Databases certainly have been slow to move to the cloud, but we're seeing an increased pace of people who are interested in moving stuff to the cloud. A lot of the concerns about security and reliability, they're still there, but they've definitely diminished over the past year or two. And it appears as though when we talk to customers or people who are using Postgres, there's still, most databases are in internal hardware, but there's a lot of value and researching and sort of proof of concept and even deployment from big organizations where they're moving a lot of their non-critical things to the cloud. And why is that? Well, first off, as you may know, maintaining your own hardware, and I have a server right over here to my left, maintaining your own hardware is not easy. You have to get the hardware in, you got to rack it, you got to handle failures. You've got to purchase, you got to size it. you've got to maintain it, right? You have to maintain the power and the network and the hardware. And if any of those fails, it's kind of on you if you're using your own infrastructure. If you're using the cloud, all those problems push out to a much larger team, right? Remember I talked about the Google data center where they have a small group of people managing thousands of servers, and you've got an economy of scale there and economy of failover and monitoring that's very hard for an organization to reproduce, particularly if they have to hire all those people to do it and test it. So that, I think, is the huge value to the cloud, is basically not having to deal with your own hardware and not having to deal with failures associated with your own hardware, and staff up, to handle those hardware. You may not need a lot of that staff most of the time, but when things go bad, you need them. Do you really want to pay that much just to have people who aren't going to be needed a lot of the time? Also, storage failure, which is probably the most common case of failure for most servers. That's also handled by the cloud infrastructure. So you don't have to sort of figure out how to, disk drive goes bad, is it RAID? Where are the drives? Who's going to put the new one in? Who's going to sync it up and make sure it's functioning properly? All those problems get pushed out. And if managing servers is not your core business, maybe you're better off in a lot of cases doing that. There are downsides, there's no question about that, but a lot of organizations, even large organizations, are not really saying if we're going to go to the cloud. It's sort of when are we going to go to the cloud, and then how much is going to go to the cloud and how much is going to stay in-house. And that decision kind of goes back and forth. Some over cloud and they move back to the physical, some under cloud, and then they sort of switch back and forth. But probably, the future looks like some kind of hybrid system where some of the stuff may be in the cloud, some of it's internal and hardware and so forth. One of the nice other advantages of the cloud, and this is very hard to do internally for small organizations particularly, is if you get busy all of a sudden, what are your options, right? Are you going to just buy a new server and then wait for it to be shipped and provisioned internally, and then to have the software installed? And probably by the time all that's done, your increase of usage may be over, right? Very hard to predict, particularly when you're talking about internet traffic. You may be all of a sudden very busy around Christmas time, right? How busy are you going to be? You don't know how busy you're going to be. What if you start losing customers if you get so busy early November, late November? You're gonna buy a rack early December and hope it gets here before Christmas so you can handle the rush? Or you see what I'm saying? It becomes, particularly with people with variable workloads, it becomes really hard to figure out, to right size your infrastructure and make sure you have all the tooling and all the hardware you need in-house. And if you guess wrong, it can take a long time to rectify that. When you're working in a public cloud, you can basically add stuff really easily. Just click of a button, credit card charge, and you've got new infrastructure, you've got larger infrastructure. So again, a lot of organizations have had to over provision because they didn't know exactly how much they needed, but they knew if they under provisioned, they risked. Now you kind of, with the cloud, you can under provision, and if you may guess wrong, within an hour or two, you can be on a larger VM with more resources, and you're out of trouble. So again, if you have spiky workloads, this kind of cloud capability become very. In fact, AWS kind of developed its own. Amazon developed AWS primarily to handle that spiky workload problem within the organization, and then realized other organizations might have similar problems and might like to have infrastructure as a service, and that's how AWS is born. So again, it's not an academic question. It's actually it was actually the reason that AWS got created, because Amazon had that exact problem. And finally, and I don't want to belittle this item, cloud can be expensive. There's no question that having your own hardware, if you size it right, over the years that you use it, can definitely be cheaper than a cloud deployment. But you have to factor in the staff time and the inflexibility that you have. and determine whether that makes sense or not. So a lot of people say, well, I can have my infrastructure that costs X. I can have my cloud infrastructure that costs Y. They're two different numbers. Yeah, I get that. But how much staff are you paying to have the in-house infrastructure? And do we add that to the cost of the in-house infrastructure? And if we do, is it still less than the cloud, right? Hard to say. But the industry is definitely going through some changes, and we're going to continue to see that going forward. So there's actually, and I've talked about cloud in a very generic sense, but I want to drill down to exactly what options you have. There are really 4 different ways of deploying in the cloud, because everyone keeps talking about cloud, but what exactly are they talking about? So the one example, and this is actually not a cloud case, but just a pure container case, are private servers with containers and Kubernetes. Okay, so this is a case, this is not really a VM situation, or not really a sort of public cloud situation, but just using Kubernetes and containers within a private data center. Okay, and those are very easy to deploy. You know, that is a completely legitimate way. Particularly if you have a whole bunch of departments, they all have different needs, you can kind of simulate the advantages you have in public infrastructure. So for example, one department may be very busy around Christmas, the other department may be very quiet around Christmas. That one busy department during Christmas can take a lot of containers and make them really big. We can shrink the containers for the departments that aren't busy. Then obviously when after Christmas, we kind of put them back to their normal size, or maybe make the other one bigger when they get busy, maybe in the summer, some departments. So you can see how even in a containerized, without really a cloud infrastructure around you, containers and Kubernetes kind of allow you to kind of set up and automate the deployment, as we talked about, automate the scaling, giving people more infrastructure as you kind of move around. The second option is a little more sophisticated. This is a private cloud. So instead of giving people containers and moving the containers around, you actually have virtual machines. So these are VMs. They can be running different operating systems. If they're going to use containers, they're going to be running Linux, but each VM is its own Linux operating system. Okay, and then on top of that, you put containers. And the advantage there is you can use different operating systems. So you're not stuck with like a single operating system for all of the people in the entire organization in the private cloud. You can put different operating systems together because you're using a private cloud, and sort of mix and match what you do. Because instead of using containers, you're using VMs, which you then may put containers into if you so wish, or you may just use virtual machines and not use containers at all. But again, that's all private, but there are similar advantages to doing that because you're automating the deployment and you're centralizing the management, and hopefully you're getting more economies of scale because you're not having each department manage their own servers. And plus, you can scale up and down the sizes of the VMs and the containers as necessary. Third option is the public cloud. And this is the Amazons, the Azures, the Google Cloud, Alibaba, that are basically available around the world. Typically, there's a web interface you configure it with. I have a presentation on my website about installing Postgres in the cloud the hard way, which actually does it from the command line. You can actually do that with AWS, install Postgres from the command line without a GUI at all. But typically, you use a GUI and you sort of create your VMs and your storage, and then you basically deploy your version of Postgres. So you pick an operating system, and then you basically use a package manager and you install Postgres on that operating system, and you start it, and then you point your applications or whatever at that running server that exists in the cloud. Okay, so it has all the benefits of the previous one, except that now you don't manage the infrastructure anymore. You don't have to manage the failures anymore. That's now all in the cloud provider, and you don't have to worry about it. But there's typically going to be more expensive because you're not, but it's not your hardware anymore. You're renting that hardware for a specific time, and you have to be careful. How much is it going to cost me to have the VMs running? How much is it going to cost me for storage? How much is the networking going to cost me? And then you get a bill at the end of the month or whatever. And then you have to decide, is that a good, is that a good use of my time, depending on the criteria we just talked about earlier. So that's kind of the third option, is to go to the public cloud, self-installed software, but now the infrastructure is not private, the infrastructure is public, and you're now renting that infrastructure, and you're now outsourcing the management of that infrastructure and the failure handling of that infrastructure to the cloud vendor. The fourth one is, kind of at the end, and the one that probably requires the least amount of work in your organization, but typically is the most expensive. And that is a public cloud where you're using cloud-specific software. So you're using typically some type of database as a service, whether it's RDS Postgres or Azure Postgres on Amazon, or so forth. So these are basically database services. So not only are you not managing the hardware, you're not even managing the database anymore, at least in terms of sort of failing over. And typically they come with backup tools. Typically they come with monitoring tools. They typically will auto-tune it for you. They will typically handle disaster recovery for you. So again, this is kind of at the top end, where we're now, not only are we renting the hardware from the cloud vendor, we're allowing them to basically control the software as well, the database software. And they're just basically giving us a connection to a database that they have provisioned, and then we will use that as much as we want. And we will pay for it, because we are asking them not only to give us hardware and to handle failures of that hardware, but we're asking them to manage the database and handle failures of that database. Okay, so that's kind of the distinction, I would say, with going to what we call a database as a service, or a case where you're using a public cloud and you're not even installing on top of the operating system. Everything is pre-configured for you. Which option is best for you? It depends. Depends how good your teammates are, how much they like to do work in-house, how much, how familiar we are with handling these types of things, and how much you want to outsource, and how much you want to pay for that outsourcing is really the issue. So typically cloud-specific software, we're talking about that last item, where you've provisioned the hardware and the software and the database software. The typical cloud-specific database software can handle things like the storage, high availability, backup, restore, monitoring, scaling. Sometimes they have persistent memory, sometimes GPUs. But the thing people like about this is there is a single vendor to blame, because you don't really have a whole lot of control of the software. So everything is really responsibility of that vendor. If it doesn't work, that is the vendor that's responsible. It's not the problem of the way they deployed Postgres in the VM. It's not the problem of how they did failover. All that stuff is now the responsibility of a single vendor, and that is attractive to some organizations, because then anything bad that happens in that sphere can then be pointed at and can be corrected with a single vendor. So that can be attractive. So in conclusion, containers, the big win for them is that they ease database deployment. And that's what we've kind of been talking about, the ability to automate not only the deployment of the database, but the tools also are very important when you're trying to deploy at scale. Public cloud can reduce complexity because you don't have to manage the hardware. The hardware is managed obviously remotely. And cloud-specific software is sort of the the ultimate step of outsourcing, where even the software itself is not managed by you. The database is provided as a service, and the vendor is really responsible for that service. So I want to thank you for that. I enjoyed kind of talking to you about this sort of landscape of where not only things have gone in the past in terms of getting to large data centers, but then the evolution of the containers and the container deployment, and finally cloud and cloud specific software kind of is the natural evolution of all of those forces kind of coming together to give you a range of options that you never really had before. And organizations are still, I think, getting it around their head that these are now viable options. They may not be viable for everyone, but they are now viable options, all the way from single dedicated hardware to private cloud, public cloud, and then managed service cloud database software. These are all options now that all organizations are considering. And the challenge is for you to understand which one fits your needs the best. You got a lot of choices now you got to decide. So thank you very much. That was the kind of goal, to kind of give you that broad spread of the options that are now available, and particularly for databases, because cloud and containers, had a huge hype for sort of applications that could be started and stopped quickly. Databases, they're in a little different space. They're much stickier. They're very stateful. And I've tried to highlight where databases make sense for that particular type of solution. So thanks very much. And I enjoyed speaking to you today.